Hi, I'm Giles Gordon, and in this video I'll be describing the types of parallel processing as well as its architecture and applications. Parallel processing involves taking a problem and breaking it down into smaller parts, and then computing those at the same time rather than computing the entire problem sequentially, which takes substantially longer. The ways in which problems are broken down vary with the problem. Bit-level parallelism is a way to expand the size of a processor to do a computation with values that have sizes larger than the greatest word size of a processor, thus decreasing the unnecessary amount of instructions. For example, say the word size of a processor is 8 bits, and we need to add a value with more than 8 bits. By utilizing multiple processors, it's possible to complete the operation in one instruction. Then there's instruction-level parallelism, which refers to the use of multiple processors to complete multiple operations in one clock cycle by pipelining instructions. Once instructions are completed, the results can be regrouped. There's task parallelism, which is used to break down a task into subtasks and compute those tasks on different sections of the same data. And finally, we have data-level parallelism, which is when the same instruction is operated on multiple data. The use of multiple processors is an important aspect of all forms of parallel processing, and there are many ways to create a system capable of supporting parallel processing. Without the hardware supporting multiple processors, it's impossible to take advantage of the increased efficiency of parallel computing. That's why most personal computers nowadays have a multi-core processor, which contains multiple processors on a single chip. It's also possible to have individual computers communicate over the internet to process in parallel. Flynn's taxonomy is a way to describe the multiple categories of computer architecture used in parallel processing. The four categorizations commonly used are SISD, SIMD, MISD, and MIMD. SISD, or single instruction, single data, is what we think of when talking about the traditional von Neumann model. In this design, processes are computed sequentially, with its speed capped at the internal computational speed of the computer. SISD machines by themselves can't actually do parallel processing, since there is only one processor, but they can if they are connected together in a parallel processing cluster. SIMD, or the single instruction multiple data architecture, is a structure in which multiple processors execute the same instructions synchronously on a data vector. This is useful for things such as matrix multiplication, where the same data is repeated on different data. MISD, or multiple instruction single data machines, are used to do different operations on the same data simultaneously. These systems are not as useful as the others, and are not produced commercially. And finally, MIMD, or multiple instruction multiple data machines, are capable of asynchronously computing multiple instructions on multiple datasets. Some MIMD machines have tightly grouped processors with a shared global memory, while others are more loosely coupled and have distributed memory. These categories are a way to organize the many structures in which processors can work together to speed up tasks. Thanks for watching.